Hi friends, welcome to Master Your Maths session. Today we will be looking at rational and irrational numbers, how to identify these two different forms of numbers and how to convert decimals to fractions. Now, what are rational numbers? Rational numbers are those numbers that can be represented in the form P by Q. Now, if you take integers, all integers are rational numbers because they can be written with 1 as a denominator. Minus 2 can be written as minus 2 by 1. 543 can be written as 543 by 1. Even 0 can be written as 0 by 1. So, any integer is a rational number. Fractions are already in the form P by Q and hence they come under the category of rational numbers. Now decimals, we have to be careful and figure out which are the rational numbers and which are the irrational ones. Those decimals that are terminating, that is, they have a finite number of digits, then they can be converted to the form P by Q and hence they come under the category of rational numbers. If the decimals are recurring, such as this 5.3 dot, which means 5.3333, we have an infinite number of threes. Similarly, the 7.25 dot would mean 7.252525, an infinite number of 25s following the 7.7 and the decimal point. So these are recurring decimals and these can also be converted to the form P by Q. Hence they are also rational numbers. Whereas irrational numbers are those numbers that cannot be represented in the form P by Q. Decimals that neither terminate nor recur, that is, the decimal number such as this, it is just going on and on. It is neither ending nor is it recurring like these here. So it is called an irrational number and it cannot be expressed in the form P by Q. Similarly, this 1.060060006, this seems to be following some sort of a pattern, but again, it is neither terminating nor recurring and hence it is an irrational number. Now, square root of numbers such as 3, 5, which are not perfect squares, you will see that they just go on and on without terminating or recurring. Root 3, for instance, is 1.732 dot dot dot. It just goes on and hence it is an irrational number. Similarly, root 5, root 7 are all irrational numbers. Now, pi is also an irrational numbers. You would have learned that pi can be represented as 22 by 7 or 3.14, but these are just approximations of the actual value of pi and hence pi is an irrational number. So I hope it is clear now what are rational and what are irrational numbers. All integers and fractions will come under the category of rational numbers. As far as decimals are concerned, those decimals that have a finite number of digits or those that are recurring will come under the category of rational numbers. Those that neither terminate nor recur are irrational numbers, and root 3, root 5, etc. are irrational numbers. Pi also comes under the category of an irrational number. Now I think you will easily be able to identify which numbers are rational and which are not. Now let us move on. And now we will see how to convert decimals to fraction. First, we will take some examples of terminating or finite decimals. Now, if I consider 1.3475, I can just multiply this with 1 followed by 4 zeros since I want to get rid of the decimal point. When I multiply by 10,000, I also have to divide it by 10,000. So 13,475 divided by 10,000. This is in the form P by Q. We also have to cancel it out using any common factors so as to get the simplest form of the fraction. I'm not going into that right now. I'm sure you can cancel this by 5 and you can bring it to its simplest form. Similarly, 4.92. Yes, 4.92 can be multiplied and divided by 100. So to get rid of the decimal place, we multiply by 100. Since we are multiplying by 100, we also divide by 100. So the answer would be 492 by 100. Again, we cancel this out using common factors so that we bring it to the lowest form of the fraction. Here it should be divisible by 4. So if I cancel by 4, I'm going to get 1, 2 and then 3. 123 divided by 25. So this is a fractional representation of 4.92. Now this is simple, isn't it? Terminating decimals conversion to fraction is very simple. Recurring decimals also, once you know the method, it is going to be simple. Let us see how to convert recurring decimals to fractions. Now, if we take into account 45.3 dot, I told you this dot on top of the 3 means there are an infinite number of 3's following the 45. So let me take this to be equal to x. So x is equal to, let me write it as 45.3333 just so it is easily understandable, the method that I am going to follow for this. Now, if I just multiply this by 10, okay, now the decimal point will come immediately after this recurring decimal, right? And this would become 10x is equal to 453 point. How many 3's will be there now? There will still be an infinite number of 3's because just taking off 1 3 from that is not going to change the infinite number. Now we can now subtract x is equal to 45.3333 from this so as to get rid of the recurring numbers and convert it to a fraction. So this and this would get cancelled. When I subtract, I'm going to get a 9x here and this is going to be equal to 13 minus 5, 8 and here it would become 4, so 0, 408. So my x would be equal to 408 by 9. Again, these are divisible by 3. 4 plus 8 is 12. So this number is divisible by 3 and so is 9. So let me divide it by 3. I'm going to get 3 ones 3. Then there is 10. So 3 3 is 9. Then it will become 18. So 3 6, 18. So it is 136 by 3. Alright, so this is how we convert a recurring decimal to a fraction. Let us take a few more examples of recurring decimals. Now here the recurring decimal is 0.85 dot. Since the dot is both on the 8 and the 5, it means that it would be 0.85858585. So let me again equate it to some unknown x. So I would get 0.858585 repeating an infinite number of times. As in the previous problem, my aim would be to bring the decimal point immediately after the recurring decimals. So here, since there are two places that are recurring, I would have to multiply this by 100. So if I multiply it by 100, I'm going to get 100x is equal to, here I will get 85.858585 dot dot dot. So now as I told you, both of these are infinite number of 0.85s which can 0.85s which can be cancelled out. Now again subtracting, we are going to get 99, x is equal to 85, x is equal to 85 over 99. Now this is the fractional representation of this recurring decimal. All right. I will take a few more examples. Now consider 9.382 dot. The dot is on the 3 and the 2. So that means 3, this 2 and anything between it also will repeat. Is it not? So obviously that has to repeat if the 3 and the 2 are repeating. So let me again take x is equal to 9.382382382 dot dot dot. Now my aim being to bring the decimal point immediately after the recurring decimals, I would have to multiply this by, yes, 1000 in this case. So 1000x is equal to 9382.382382 dot 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 dot. This is going to repeat an infinite number of times. Now, if I subtract x is equal to 9.382382 here, I can subtract these two. So the recurring portion will again get cancelled. So I am going to get a 999 is equal to 9373. All right. So 999x, I'm sorry. So x is equal to 9373 divided by 999. Let us check if these are divisible by 3. No, the numerator is not divisible by 3. 9 plus 3 is 12, plus 7, 19, plus 3, 22. So we can leave it in this form. All right. So now all the three problems that have seen, the decimal place immediately precedes the recurring decimals. Here there are three recurring decimals immediately after the decimal place, and here there are two decimals immediately after the decimal place. There are two numbers which are recurring. Here there is one digit that is recurring. Now if you look at this problem here, we find that there is the recurring digit is this 2, and there is another digit here between the decimal point and the recurring digit, right? So what we do to solve this problem is slightly different from the previous problems. Let us again equate it to x first. So x will be equal to 15.42 dot, or let me write it as 4222. So now I will only be able to cancel out the 2 2's, right? So first I bring the decimal point immediately before this recurring decimal. So I will have to multiply it by 10 in order to bring my decimal point immediately before that recurring digit. Now we proceed as we did in the previous problem. So we try to take the decimal point immediately after the recurring digit. Since there is only one recurring digit, we multiply by 10 again, but we multiply this equation by 10. So we are going to get 100x is equal to 1452.222. And we subtract this 10x is equal to 154.222 from it. Only then I will be able to get rid of my recurring digits here. All right. So I cancel out these two. And here I have 90x is equal to 12 minus 4 is 8. Then I have 13 minus 5 is again 8. This will become 4. So 14 minus 1 is 3. 1388. So x is going to be equal to 1388 by 90. We can cancel both the numerator and denominator by 2 to bring it to its simplest form. So this is the decimal representation of fractional representation of 15.42 dot. So let me do one more problem where the decimal point does not immediately precede the recurring digits. So we will see how to go about solving it. Now, if you see this problem here, x is equal to 14.289 dot. So I would like to bring my decimal point immediately before the recurring digit. So I have to multiply by 100 since there are two digits here between my decimal point and the recurring digit. So 100x is equal to 1428 point. I will write this as 999 for better understanding. It can also be written as 9 dot and the 9 dots can be cancelled out. Now my aim would be to bring the decimal point immediately after the recurring digit, that is here. So from here to bring it here, I just have to multiply by 10, but I have to multiply this equation, preceding equation by 10. So 1000x would be equal to 14289.999 dot dot dot. And subtract this 100x equal to 1428.999 from it. So as always, the recurring digits get cancelled. So 9 minus 8 is equal to 1, 8 minus 2 is 6, 12 minus 4 is 8. So this would become 3, 3 minus 1 is 2, 12,861. And here I get a 900x. So my x would be equal to 12,861 divided by a 900. I hope this method is clear to you now. So let me just summarize. We first put x equal to the given decimal with recurring digits. Then we multiply the decimal and the x on the left hand side by a power of 10 so as to bring the decimal place just before the recurring digit or digits. So my first step would be to bring the decimal point immediately before the recurring digits. If the decimal is already just before the recurring digit, we don't have to do this step at all. Then we multiply the above equation, that is either x equal to some 9.382, such an equation, or 10x is equal to 154.222. So the equation will have decimal point immediately preceding the recurring digits. So we will multiply that equation by a power of 10 so as to bring the decimal place just after the recurring digits. In other words, you have to multiply it by 10 if there is one recurring digit, by 100 if there are two recurring digits, 1000 if there are three recurring digits, and so on. Now we subtract the equation in step 2 from the equation in step 3 and simplify to find x in a fraction form. Wherever required, we will have to reduce the fraction to its lowest terms. So this is the summary of the steps involved in converting a recurring decimal to a fraction. I hope this was clear to you. I have given a small exercise for you to practice. So please practice these problems and then you can check with the answers that I have given here. In case you have any doubts, you can contact me in the comment section. You can post a comment and you can contact me. If you like this video, if you found this useful, you could follow Master Your Maths, other videos in Master Your Maths. Thank you. I hope you found it useful.